So, good morning class. Today we will discuss about chemical properties or chemical reactions of alcohols. So, we have already discussed about classification of alcohols. We have discussed about classification of phenols, and today we will discuss about chemical reactions of alcohols. So, when we are discussing about chemical properties of alcohols, in that case we have to discuss mainly three categories of reactions. Three categories of reactions we have to discuss, and they are: the first one is reactions involving cleavage of OH bond, that is, this bond will be cleaved, or the second one will be reactions involving cleavage of COH bond, that is, this bond will be cleaved, and the third one is reactions involving both alkyl as well as hydroxyl groups. Alkyl as well as hydroxyl groups. So, in the first category of reactions, that is reactions involving cleavage of OH bond, we have to discuss further 6 types of reactions in this category. 6 category of reactions. In that case, the first reaction would be acidic character of alcohols. Acid character of alcohols. Second would be reaction with active metals. Third one is reaction with metal hydrides. Fourth one is reaction with Grignard reagent. Fourth one is reaction with sulfuric acid. Also called esterification reaction, because it leads to the formation of esters, hence called esterification reaction. And the last one is reaction with acid chlorides and acid anhydrides. So, these are the 6 category of reactions in the cleavage of OH bond. So, next is reactions involving cleavage of COH bond. In that category, we have to discuss further 4 types of reactions. So, the first is reaction with hydrogen halides. Second is reaction with phosphorus halides. Third one is reaction with SoCl2, that is sulfonyl chloride, and the fourth one is reaction with ammonia, leading to the formation of amines. And the fourth category, in which we have to include both alkyl as well hydroxyl groups. In this category, we have to discuss further 4 types of reactions. The first one is dehydration. Second one is oxidation. The next would be dehydrogenation, and the fourth would be halogenation. And in case of dehydration, we will further discuss about Sayzeff rule. Sayzeff rule in case of dehydration of alcohols. So, see, these are the total chemical properties or chemical reactions that we have to discuss in case of alcohols. So, in case of chemical properties of alcohols, we have to discuss three categories of reactions, that is reactions involving cleavage of OH bond, reactions involving cleavage of COH bond, and reactions involving both alkyl as well as hydroxyl groups. So, in the first category, when we have to discuss about cleavage of OH bond, in this category we have to further discuss about 6 types of reactions, that is the first one acid character of alcohols, second one is reaction with active metals, third one is reaction with metal hydrides, fourth one is reaction with Grignard reagent, fifth one is reaction with sulfuric acid leading to the formation of esters, hence also called esterification reaction, and the last one is reaction with acid chlorides and acid anhydrides. In the second category, when we have to discuss the cleavage of COH bond, in that we have to discuss 4 types of reactions: reaction with hydrogen halides, reaction with phosphorus halides, reaction with thionyl chloride, and reaction with ammonia, that is NH3, leading to the formation of amines, primary amines, secondary amines and tertiary amines. And the next is reactions involving both alkyl as well as hydroxyl groups. In that case, we have 4 reactions. In that case, we have further 4 types of reactions, where reactions involves both type of groups, alkyl as well as hydroxyl groups. So, there are 4 reactions: dehydration, oxidation, dehydrogenation and halogenation. So, in case of dehydration, we will further discuss about Sägesfrö. So, this will be the entire different types of mechanisms of reactions that we will discuss in case of alcohols. So, let us discuss each one of them in detail. Next, so let us start from the first one, that is the first reaction was reactions involving cleavage of OH bond, that is this bond will be cleaved. So, in this category we have to discuss 6 types of reactions. Already we have seen the flow chart of reactions. So, let us see the first one, that is acid character of alcohols, acid characters of alcohols or acidic character of alcohols. So, in that case, whenever we are considering about any alcohol of the form, it will be of the form ROH. This is alcohol. So, if it is acidic in nature, that means it will donate its proton, and after donating proton, the remaining group will be like this RO, and it will have a negative charge over here over oxygen atom, and plus a proton would be evolved. So, after donating this proton, this H plus ion, the remaining part, that is RO minus, this is called alkoxide ion. This is called alkoxide ion, and this is the proton which has been removed or it has been donated from alcohol molecule. And according to the arrangement or decreasing order of the acidic characters of different types of alcohols, that is primary, secondary and tertiary alcohols, the most acidic are the primary alcohols. Primary alcohols are the most acidic. Then is the category with secondary alcohols, and then will be the case with tertiary alcohols. So, primary alcohols are the most acidic and tertiary alcohols are the least acidic, and this is the order of arrangement of decreasing order of acidity, decreasing order of acidity. So, this is the decreasing order of acidity. So, we are discussing about the cleavage of OH bond, and when we are discussing the cleavage of OH bond, we are discussing with the first reaction, that is the acidic character of alcohols. So, whenever alcohol is donating electron or it is donating proton, so it will show its acidic character. So, the alcohol molecule, after donating its proton, it is converted into alkoxide ion, and since it is donating this proton, hence we can say that alcohols are acidic in nature. So, after donating proton, it is converted into alkoxide ion with the elimination of proton, that is H plus ion. And if we arrange the three types of alcohols according to their acidic strength, so according to that category, primary alcohols are the most acidic, then is the case with secondary alcohols, and the tertiary alcohols are least acidic, and this is the arrangement, or this is the decreasing order of acidity, most for the primary alcohols and least will be the tertiary alcohols. So, this was the first reaction among reactions involving cleavage of OH bond. So, let us move on to the next reaction in the same category, that is B reaction, that was A. B will be reaction with active metals, like sodium, potassium, calcium, it can be any active metal we can take for the case. So, let us say an example. For example, let it be ROH, this is the alcohol, we are writing a general reaction for this category. So, when alcohols are treated with active metal, let it be sodium. So, when this alcohol is treated with sodium, what will happen? This sodium, or we have already seen that there will be a cleavage of this OH bond, in which this proton will be eliminated in the form of H plus ion, and this sodium ion will be attached to this oxygen atom, means a kind of substitution reaction will take place. So, this sodium atom will be attached to this oxygen atom, leading to the formation of RONA, and this hydrogen or this proton is eliminated in the form of hydrogen molecule. So, this was alkoxide ion, and since sodium is attached to that group, it is called sodium alkoxide. Let us take example of this category. We have CH3OH, that is methyl alcohol or methanol. So, when methanol is treated with sodium, what will happen? We have already seen the mechanism of this reaction. So, this hydrogen will be evolved in the form of H plus ion, and sodium atom will substitute hydrogen atom, leading to the formation of CH3ONA, and the two hydrogen atoms or these two protons will be eliminated in the form of hydrogen molecule. So, this is methoxide and this is sodium, and this compound is called sodium methoxide. Sodium methoxide. Sodium methoxide. Let us take one more example for this case. Let CH3CH2OH, this is ethanol, and when ethanol is treated with potassium, that is K, it is also an active metal. When it is treated with potassium, what will happen? According to the mechanism of this reaction, this hydrogen will be eliminated in the form of H plus ion, and this potassium will substitute this hydrogen atom, leading to the formation of product CH3CH2O, and here will be K, potassium atom, and the two hydrogen or the two protons will be eliminated in the form of hydrogen molecule. So, this compound will be called, this is ethoxide and this is potassium, called potassium ethoxide. Potassium ethoxide. So, this is the reaction with active metals. When alcohol is treated with any active metal, let it be sodium. So, what will happen? Sodium will substitute hydrogen atom or proton, leading to the formation of sodium alkoxide, and the two protons will be eliminated in the form of hydrogen molecule. In the similar manner, when methanol is treated with sodium, it leads to the formation of sodium methoxide, and a liberation of hydrogen molecule will take place. And in the same manner, when ethanol is treated with potassium, potassium will substitute this hydrogen, leading to the formation of potassium ethoxide, and the two protons will be eliminated in the form of hydrogen molecule. Now, let us see the third category of reaction. Third category of reaction, that is C, reaction with metal hydrides. Reaction with metal hydrides. So, we are going to discuss reaction with metal hydrides. So, let us see what is the kind of reaction this one and what is the mechanism behind this reaction. So, if we have an alcohol of the form ROH, this is alcohol, and when it is treated with metal hydride, let it be sodium hydride, that is NaH. So, what will happen? This sodium will substitute H, this proton, and this hydrogen will be eliminated in the form of H plus ion, and these two hydrogen atoms will be evolved in the form of hydrogen molecule. So, let us see what is the reaction will be. So, this sodium will attack this oxygen, leading to the formation of RONA, that is sodium alkoxide, and these two hydrogen atoms will be evolved in the form of hydrogen molecule H2. So, let us see example for this case. Let us have CH3OH, which is methanol. When methanol is treated with sodium hydride, that is NaH, then again the same thing will happen. This hydrogen will be evolved in the form of proton H plus, and this sodium atom will attack this hydrogen atom, leading to the formation of CH3ONA, and these two hydrogens will be evolved in the form of H2. So, its name would be sodium methoxide, sodium methoxide, sodium methoxide. Let us take one more example of this case. CH3 CH2 OH, this is ethanol. When ethanol is treated with potassium hydride, that is KH, what will happen? Again, this hydrogen will be eliminated in the form of H plus ion, and this potassium will substitute this hydrogen atom, leading to the formation of CH3 CH2 OK plus H2 hydrogen molecule, and this is called potassium ethoxide, potassium ethoxide. So, this is the complete reaction of metal hydrides with alcohols. So, this is the third category of reactions with metal hydrides. When alcohol is treated with metal hydride, let it be sodium hydride, then it will lead to the formation of sodium alkoxide and evolution of hydrogen molecule. In the similar manner, when methanol is treated with sodium hydride, it leads to the formation of sodium methoxide, and a molecule of hydrogen is eliminated or it is evolved. And when a molecule of ethanol is treated with potassium hydride, it leads to the formation of potassium ethoxide and elimination of hydrogen molecule. Now, let us see the next category of reaction. Let us see the next category of reaction, that is D, reaction with Grignard reagent. Reaction with Grignard reagent. Reaction with Grignard reagent. So, what will happen in this case? Let us see reaction with Grignard reagent. When a molecule of alcohol, let it be ROH, this is alcohol, when it is treated with Grignard reagent, let the Grignard reagent be of the form R dash MgX. So, this is of the form. So, what will happen in this case? This R dash X, it is eliminated, and this OR group called alkoxy group, and it is this OR group is attached to magnesium, and halogen atom is also attached to this magnesium atom. So, let us see what will be the product. So, this R dash H is eliminated, and it will be R dash H, it is alkane, an alkane is formed, and this magnesium atom is connected to two groups, that is to X group and to this alkoxy group. So, magnesium atom is linked to alkoxy group, that is OR group over here, and the halogen group over here. So, it is called alkoxy magnesium halide, alkoxy magnesium halide, and this is alkane. So, this is the Grignard reagent. Grignard reagent, and this is alcohol. So, when a molecule of alcohol is treated with Grignard reagent, so what will happen? The R dash group from here and the hydrogen atom from here, it is eliminated in the form of alkane, and this magnesium atom is doubly bonded to this halogen atom of X group of Grignard reagent and the alkoxy group of alcoholic part, leading to the formation of MgORX called alkoxy magnesium halide. So, this is a general reaction for the reaction with Grignard reagent. So, let us see an example of this case. We have methanol CH3OH, this is our alcohol methanol. When methanol is treated with Grignard reagent, let it be CH3MgBr called methyl magnesium bromide. This is methyl magnesium bromide. So, when the two are treated, what will happen? Let this hydrogen atom be shown with a bond. So, what will happen in this case? It is eliminated, the hydrogen atom from here and the methyl group from here, it is eliminated, and the Mg atom is doubly bonded to this bromine and this methoxy group. So, it leads to the formation of this CH3H, this CH3 combines with this hydrogen atom to form CH4, which is an alkane called methane, and this magnesium atom is attached to this group of methoxy group and this bromine group, plus MgOCH3 from here and bromine from here. So, its IPC name would be methoxy magnesium bromide. Its IPC name would be methoxy magnesium bromide, methoxy magnesium bromide. Okay. So, in the case when Grignard reagent, when alcohol is treated with Grignard reagent, leads to the formation of alkane and alkoxy magnesium halide. In the similar manner, when methanol is treated with methyl magnesium bromide, which is our Grignard reagent, it leads to the formation of methane and methoxy magnesium bromide. So, this is the complete mechanism of reaction of Grignard reagent with alcohols. Now, let us move on to the next reaction. Let us move on to the next reaction. Fifth reaction, that is reaction with carboxylic acids, reaction with carboxylic acids in the presence of concentrated sulfuric acid, which is a dehydrating agent, because there will be evolution of water molecule. So, let us discuss what the case would be. So, when a molecule of water, when a molecule of alcohol, let it be of the form ROH, when it is treated with a molecule of carboxylic acid, this is carboxylic acid, and when the reaction is carried out in the presence of concentrated sulfuric acid, so there will be a elimination of water molecule. So, the water molecule will be eliminated in this form, and this RO group would be attached to this. So, what will happen? The compound would be like this: C double bond O, here it would be R dash, and here it would be OR, and this is ester, and this entire process is called, because it leads to the formation of ester, hence this process is called esterification reaction. Esterification reaction, because it leads to the formation of esters. It is called esterification reaction. So, let us discuss a case of this kind. So, when methanol, that is CH3OH, when methanol is treated with acetic acid in the presence of concentrated sulfuric acid, which is a dehydrating agent. So, water molecule will be eliminated. This is methanol, and this is commonly called acetic acid, or IPCN would be ethanoic acid. So, there will be a elimination of water molecule, and this CH3O group would be attached to this carbon atom, leading to the formation of C double bond O CH3, and this will be OCH3 over here, and this compound is called methyl ethanoate. So, this is the complete esterification reaction, that is the reaction with carboxylic acids. When alcohol, this is a molecule of alcohol, when it is treated with carboxylic acids, or let it be carboxylic acid. So, it leads to the form in the presence of concentrated sulfuric acid. So, there will be elimination of water molecule, it leads to the formation of ester.